Have you ever wondered how things go from inside your brain to being made in the shop? How does an inventor tell the people who are making the thing for him exactly how he wants the thing to work? For that matter, you should have some idea as to what you're going to make for your final project by now. How are you going to let me know what that project is so that I can approve it? Well, what we're talking about, that manufacturing, that industry, that house building uses, is blueprints. Now, we're not going to make a specific blueprint like they would in a shop. What we are going to do is sketch to scale. And what we're going to learn today is about scale, about actual lines that we do when making these sketches, and what information and text will go on the actual paper. An actual blueprint will contain lots of things. This is a piece that any welding company may be asked to make. The manufacturer may ship out the individual pieces to be made at somebody's shop. Somebody who's building something in Chicago may send this to Florida to have 1,000 of them made. Now, by looking at the blueprint, we really don't know exactly what it looks like because it's like a foreign language to us. But by the time we realize what all the different lines, all the different information, and what the three views show us on a blueprint drawing or a scaled drawing, we realize that this becomes this part. The people who make these things, who are in the business of manufacturing parts or things for larger companies, inventors, creating things, use these type of drawings with all the various amounts of information to show this is what I want. Now, one of the very first things we have to decide when we're sketching is what scale we're going to use. In other words, how am I going to represent this piece, or a piece as big as a house, to fit onto our grid paper? To do that, we figure out what proportion. Scale is the same as proportion. We represent our original piece on the paper. A typical scale that we'll use for our parts in class for our learning purposes is half scale. Examples of scales, if you've ever made models. A scale means how big in proportion the real thing is to the small thing. How big will the real thing be represented by the sketching in our paper? If you've ever played with a toy car, it is a scale or proportional image of the original. Model trains are scaled or proportional sizes of the big real trains. We are going to make a proportional drawing on the paper so that we can see how to build something. Scale means something on our paper represents a real measurement in real life. If we are drawing half scale, in other words, if this is going to be a half the size to fit on our paper, you can draw it, you can say that or write that any number of ways. In other words, if this was half scale, I would take this measurement and say it's 4 inches. I would make it 2 inches big on our paper. Now, our paper that we're using has grids every ½ inch. So if we make something half scale, which we will put down here in the box where it says scale, we can write it several different ways. We can write 1 inch equals 2 inches in real life, which means 1 inch on paper equals 2 inches in real life. The same way to write this scale is to write it 1:20 in an actual proportion, or you could just write half scale. Obviously, if you're building something big, a car, a house, the scale is going to be different. It may be Down here in the scale box, you may have to write 1 inch on paper equals 1 foot in real life, or 1 inch may equal 10 feet in real life. But either way, you utilize the grids on our sketching paper to represent what the thing looks like. Our grid paper has a few features that we will use for it. Like I said, the different blocks on the grid that we use are a 1/2 inch apart, which makes it real easy to draw something at half scale. If it's 1 inch in real life, it will be 1/2 inch on our paper, or 1 block. A few things you need to put. We have title blocks on our sketching paper. Up at the top it says Fox Valley Career Center because I use it for both classes. Under that is the name block. You'll write your name there, or you won't get credit for it. When you come down to the bottom 3, there's a place for date, the date that you drew it, title, the name of the piece, and scale, or the proportion or dimension that you're using. All that information needs to be done in those title blocks before you even start. The next thing that we need to talk about are the types of lines that we use when we're sketching. There are basically 3 types of lines that you're going to use on your paper to represent your object. The first is object lines. They are what you see when you look straight on at the object. We're not drawing 3-dimensional. We'll talk about the 3 views in just a second. But what you see when you look at the object is what you draw. So if my object is the cube and I'm looking at it perfectly 2-dimensional, I see basically a square when I look through there. So my object lines on a cube for this view, pardon my straight lines, would basically look like this. The next set of lines that we use are hidden lines. They are used to show kind of like X-ray vision from a view. On this object, if I were to draw my object lines, I have a line here, a rectangle here, and basically 2 lines here. It would look something like with the rectangle in the middle. Now, when you use a hidden line, it represents what object line you could see if you had X-ray vision. Basically, the top of this triangle, the top of my piece of angle iron, there is a line back behind this rectangle that I can't see. So to show that this piece goes all the way through, I draw a hidden line which stands for this object that is hidden behind the square. For example, if you had X-ray vision, the hidden line represents an object line that you can't see, and it is a dashed line. The last thing we use are dimension lines that show basically what it says, how big something is. So if we jump up here, let's hide our hidden lines, and let's add dimension lines to our cube. Now on paper, it's going to look like a square. In real life, is this 1 inch big? Is it 10 foot big? Is it a dice? Or is it a tractor trailer? We need to have some lines that we can add some information into that shows us how big it is. Our dimension lines are going to show our borders of the piece with little arrows to each edge, and then we will write our information in there. The information that we would put in this one is 4 inches. Now, no matter how big it is on our paper, and just don't forget, we're sketching it, it's not perfectly drawn, we're just taking our graph paper and making it look like the object itself. We take and use our dimension lines to go ahead and tell us how big each of these object lines that we see is going to be in real life. Finally, we need to decide what we are going to put in for information in our sketches. We've already said that we can use dimension lines that basically go from edge to edge, using our arrows to show exactly where the edge is, and we write dimensions in. This happens to be 4 inches wide. So my end to this vise, if it looked like that, I would write in the 4 inches. So what types of information are we putting in? Obviously, we're putting in how long each object line should be. In other words, how long in real life the thing is. Obviously, this is more than 4 inches, but I'm drawing it to twice the size of scale instead of half scale. So you always go by the dimension that's written down. Other information we could put in would be the diameter or size and location of a hole in our piece. Let's say we're just going to draw this leg and say where the hole is. I'm just going to haphazardly represent this piece right here. The center of the hole, or where the hole is located, is marked by a crosshair. Now this would obviously then go in and you draw the circle of the hole. Now you got to know 2 things: the size of this hole and where it's located on the piece. For size, you would take a dimension line, an arrow, out to here, and let's say it's 1/2 inch diameter. So 1/2 inch with a small d, which means this hole in real life should be drilled to 1/2 inch. The other thing you have to do is locate the hole, so you need 2 measurements. You need to know how far it is from here to here, and let's say that's 2 inches to that center line of that hole, and you need to know how far it is from here to here to the center line going the other way. Let's say that's 2 inches. So basically, this says go down 2 inches here, go 2 inches over, that's the center of the hole, and then drill it to 1/2 inch big. Other types of information could be anything about the object. Maybe it's all 1/8 thick steel. So you would put all material 1/8 inch steel. Maybe you need to know the size of this threaded rod. You would just write on there threaded rod 5/8 13. Okay? Means it's 5/8 thick with 13 inches, 13 threads per inch, or whatever information you need to put on. Maybe it's all aluminum. Maybe it has to have a certain kind of weld. Maybe it needs to say something on the side. Maybe it needs to be a mirror image. Any kind of information you want to put on for your part, you go ahead. Finally, maybe the hardest thing that you have to decide, or the hardest thing for people to realize, is that you're drawing a 3-dimensional object with two-dimensional drawings. And that always requires at least 3 views. A front view drawn right here, a top view drawn up here, if this is your piece of paper. You'd put a front view, a top view, and a side view. Because remember, to see every object, you're drawing it exactly what you see in one view. So if we were drawing the cube, the front view is pretty easy. It looks like a square. Now, guess what? You roll it like this, 90 degrees up, to see what it looks like from the top. That's pretty easy. It looks like a square also. Okay, back to our front view, and then roll it another 90 degrees. I'd say a cube is pretty easy to draw. All right, now the reason we have all kinds of different views, okay, here's another object that looks just like our cube did from the front view, okay? But guess what? When we roll it up to a top view, it's only half the size. It looks like I'm drawing a rectangle now instead of a square. So by this view, you would think I have, these should be drawn the same size, sorry about that. I have a rectangle instead of a cube. But when I go ahead and roll it to a side view,